They're talking about specification. All right, the TWI specification. All right. What is specification? It means to state explicitly or detail or to be specific. A requirement specification is a set of documented requirements to be satisfied by material, design, product, or service. Then it said here, specification is a document that clearly and accurately describes the essential requirement for items, material, service, including procedure by which it can be determined that the requirement have been met. And also it's a reference document. It provides guidance to test or verification for verification of each technical requirement, the contract document that must be adhered to which specify how a design shall be implemented. All right, the TWI specification detail requirement from material as they arrive on site to final inspection of end product. For senior weight inspector, the specification has to be the defining document that majority of your decisions are based on, right? All right, TWI spec has 48 pages and it will cover quality control, joint preparations, welding detail, acceptance level, equipment, consumable, material, defect repair, NDT, inspection personnel, report, WPS, WQT, PWST, hydro test, pneumatic, and also coating. To me, don't worry too much about this. As far as I know, they will not asking you about this, yeah? So please only concentrate on the topic we discussed during these 7 days, yeah? All right? All right, when using TWI spec, a good starting point to use index to find the subject of your interest in, all right? So when you read the questions, what they talk about, if they talk about WPS, you go find in the index where is WPS, the page number, then from there you open the spec, yeah? All right. It saves your time, especially in exam. Read the subject matter very carefully as it may make reference to another sections. The majority of subjects require reference to TWI spec, but some will not. All right, for this one, please find the question. I think it's at the end of the handout, appendix. I'm not sure, is it appendix 1 or appendix 2? Please find the questions. Find the question first, then let me know. All right, I think it's at the end, very end of the book, appendix. Please find the question. You got 10 questions. Let me know about this. All right. They write down specification there, specification questions, if I'm not mistaken.
Okay, got it.
All right, look at question 1, and you may find the answer on the page 9, table 1 of the spec. So I think that is table 1. And that one is less than and equal to, that the symbol for, yeah, okay. So the answer goes to C. S is the, let me check what is it S for. So here we see that S is nominal butt-weld thickness, yeah? That one. Nominal butt-weld thickness, and the symbol less than or equal to is this one, all right? So that's where the answer goes to C, all right? So everybody okay with that?
Yeah.
It's quite straightforward questions and answer. All right, number 2, in the case of ferrous double side butt-weld, which inspection method should be employed before second side weld is welded? then we need to get the section 5.2 of the spec. And I think it's under joint preparation detail. Sorry, it's under welding detail. Yeah, welding detail. Under the butt weld here. Look at the last sentence here. This shall be achieved by a suitable means to clean sound metal. This shall be inspected before commencement of welding on second site by both visual and magnetic particle inspection. So that will give us the answer of question number 2, which is D, delta. Yeah. Okay. The answer goes to D, visual and NPI. That's very straightforward. All right, number 3. What will be the largest leg length dimension? So largest leg length dimension, meaning here is maximum leg length, and the smallest stroke dimensions here, meaning the minimum, and the thickness applied or used here is 12 mm. So get 5.3 of the spec here. So the leg length here, maximum T plus 3, we have 12 plus 3, so we got 15. So that is the maximum leg length required. And for the throat thickness, 12 times 0.7. 12 times 0.7, then we got the answer, which is, in this case, the best answer goes to D. So we got this one 12 plus 3, and this one is 12 times 0.7 as a minimum. All right? All right, look at question 4. An arc has been removed by grinding and the inspection has proven acceptable. The thickness of the joint is 25 mm and the removed depth is 1 mm deep. Is this acceptable? All right, the answer given is C, but we need to check what is from the spec, all right? So look at 5.6 from the spec. All right, look at under arc right here. Where the arc has been repaired by grinding, confirmation that the thickness of the paramaterial is within the permitted tolerance. This shall be a thickness reduction of no more than 2% of original material thickness. So they ask for 2% from the original material thickness. All right. So now we do some calculations here. So the thickness is 25 here. Then we times 2%. So that will give us the answer 0.5 mm. Yeah. So 0.5 mm here is what the maximum. It's a maximum reduction thickness. But here we got 1 mm deep, which is over than 0.5. So that's where the answer goes to C. Not acceptable, as 0.5 is the maximum reduction in thickness. Got it? Yeah? All right. That's number 4. And then look at number 5. Continuous SAW is being conducted on manufacture of large I-beam, 15 meter in length. After completion of each I-beam, the recycled flux, approximately 5 kilo, has another 5 kilo of new flux added before operation continues again. Is this available? All right, then we look at 8.2, the section 8.2 of the spec. Which is under storage and handling of SAW. All SAW flux shall be stored in accordance with manufacturer recommendation. SAW flux may be recycled to provide reused flux is free from all contaminants, slag, Minsky, and other foreign material. All recycled flux shall be mixed equal amount new flux before being used, 50-50 ratio. All right, that statement gives us the answer because of they put 5 kilo and 5 kilo, that telling us they got 50% use and 50% new. All right, so that's where the answer is C. This combination of mixing new and used is adequate. Yeah, all right. Look at question 6. We start on the testing of circumferential pipe butt weld, 200 millimeter diameter and 25 mm thickness, has detected lack of fusion, 180 millimeter in length. All right. Diameter is 200 and lack of fusion is 180. So this is the two things we need to look at here. Regardless the thickness, don't worry about thickness here. The contractor has repair procedure and want to carry out repair. What will be your course of action? All right, before we start, we look at the section 10.4 for repair, where they ask for repair here. Okay, they ask for repair. Look at 10.4 under repair, defect repair and cut out here. In 10.4, rewelding, all right? So repair weld shall be limited to 25% of the original weld length, okay? 25% original weld length, that is what requirement. Maximum 25%, if it exceeds maximum, then cannot repair anymore, it must be cut out, yeah? Right. Now we do bit calculations here. Example here, we have lack of fusion, 180 mm LOF. The length is 180 mm. And we have the diameter here, diameter of the pipe. Diameter is 200 millimeter. Now what we need to do is to find the circumferential length. We need to get to know what is the length of this diameter, all right? So we got circumference length. It is circumferential or circumference? It's the same meaning, right?
Yes.
Okay, so what formula are we going to use? Pi d, yeah, pi diameter. So pi is 3.14 times with 200 millimeter from the diameter. Then we got roughly about 6 to 8 millimeter. So that is circumferential length here. We got 6 to 8 millimeter. Yeah, all right. Then the requirement there is 25% maximum allowable to repair if there is any defect. So we times with 25%. All right, let me get my calculator. Six to 8 times 25%. So we got roughly about 157. So you got 157 millimeter. So that is maximum defect can be repaired. Right. If we compare to what we have here, we got 180. So that is over than allowable maximum. All right. So in that case, the best answer goes to, right? The best answer goes to D. You insist a complete cutout because of it's beyond repair. All right. Based on 25%, that's exceeding 25%. Okay. All right. We move to question number 7. The following parameters were used on 10 mm thick stainless steel butt 12 using a thick process, 12 volt, 180 amp, servo speed 40 millimeter per minute. Witnessing this operation, what will be your course of action? So they ask for austenite stainless here. And then get the section 14.4, which is detailed for stainless steel. So section 14.4 here. In 14.4 welding details here, we have different chromium content, but we assume that the maximum chromium content here is 1.75. So that's the maximum heat input. Yeah? All right. Because the question is too general, it didn't telling us what is the chromium content. All right, heat input formula is heat input equal to arc energy times K. Yeah. So here the TIG, the K factor is 0.6. All right. Now we have volt, which is 12 times 180 amps times 60 seconds. Then we divide by 40 millimeter times 1000. And then we times with 0.6, the K factor of TIG. Yeah? All right, let me check. 12 times 180 times 60. So we have 129. We have 1290. 129,000 divided by 40,000. All right. We remove this. All right, and then times 0.6. Sorry, 129. Let me check. 12 times 180 times 60. 129,600. 129,600. Sorry about this. 129,600. So, all right, we remove 20 here. So we remove 20 divided by 400. All right, so we got 3.24, then times with 0.6. So we got heat input here, 1.94 kilojoule, all right, per millimeter. So from the spec, the maximum heat input from the spec for this type of material is 1.94 kilojoule. But what we have in our calculations, sorry, 1.75, sorry, 1.75. That's what in our spec. All right, spec only requires maximum 1.75, where during welding, when they record the parameters, they found out that it's more than 1.75. In this case, we got 1.94. So that is higher, right? So that's where the answer goes to A. All right, got it? All right, look at question 8. A procedure was conducted in PF position. So PF position is vertical up, right? Vertical up. With MMA in 15 mm thickness carbon manganese steel, the following tests were conducted: harness, macro, sideband, tensile, and impact. All right, when we have impact, meaning they are looking for toughness. Toughness value, all right? So in order to answer this, look at section 17.9. All right. Welding position. In all cases, when impact tests are not required, the position of the test will qualify for all welding positions. When impact test required, the test piece carried out in vertical up position will only qualify for vertical ups, meaning they're not allowed for other position because of there is impact test. So it will not cover other positions. So that will give us answer of B. The procedure can only use for original test positions. Okay, not for other positions. All right, question 9. Quench and temper steel has to undergo post-weld heat treatment. Which of the following is correct? In order to answer this, we look at under post-weld heat treatment on the section 19.3. All right, so we have in this PWHT here, we got carbon manganese steel, quench and temper, and also austenite duplex stainless. So what we have in carbon manganese is said the temperature is 650 degrees, all right? But in quench and temper, it said shall not exceed 600. So the difference between carbon manganese and quench is the maximum temperature. The quench temper is not more than 600 degrees C. Heating rate shall be controlled from 300. Cooling rate controlled from 300. Insulation thermocouple shall not be removed until the component temperature drop below 110 degrees C. All right? So that will give us the answer of B. Here we got heating rate from 300, that's correct. Soaking 580, that's okay because our maximum given is 600. Cooling rate control 300, correct. And thermocouple remove below 110 degrees C. But if you look at A, that's wrong because of it's more than 300. Cooling also more than 300. But the soak temperature is okay. C, heating rate control 220 degrees C. Soak temperature 450. All right. And remove thermocouple at this point. So that is wrong here. Heating control, all right, this is totally wrong. Okay? All right, question 10, the last one. The quench and temper steel 40 millimeter thick required preheat temperatures 100 degree and control interpass temperature of 100 degree. The SAW process be used. The heat input must be controlled. Which of the following confirms? All right, look at table 6A. All right, table 6A. Here. All right. So the thickness is 40 mm, so it must be here. And the preheat temperature required is 100 degree here. Then from here, we got the maximum. Is it maximum? Yeah, sorry, it's a minimum. Minimum heat input required is 3.4. It's here. Yeah? All right. Then when you do calculations, C is the best answer, right? Because from this 32 volt, the heat input, 32 times 620 times per minute here, then we times with 60 divided by 350 times 1000. Because SAW, the K factor is equal to 1. So it doesn't matter. Whatever arc energy you got here, the arc energy you got here, you times 1, the heat input still the same. Yeah? All right, 32 times 620 times 60, you got that? Divided by 350, 1, 2, 3. So we got 3.4. From here we got 3.4 kilojoule. And the rest, I think all these A, B, and D, all is below than 3.4. So that's where the answer C is the best. Okay?